picking up where we left off and checking our homework from yesterday, okay? You're checking your domain and your range, and then you're also, I've got an F for function. I also went back in and I put a check, okay? We did these top two together. All right, take a look at the bottom two. Do you have any questions about these two at the bottom? What about the range right here? Were you okay with that? Because we had that in our notes. Okay? And all of these pass the vertical line test. Now, just a reminder, the vertical line test is me taking something like a vertical line and I'm moving from left to right. And I'm making sure that there is no more than 1 point on that line at any given time. Okay? Oh, shoot. That was page 22. I'm sorry, y'all. Let me go back and let's start on page 20. My bad. Did I have y'all questioning yourself? I'm so sorry. Good thing is we got the pictures here. Okay? All right, make sure that you are checking your highs and your lows and your lefts and your rights. Okay, questions? Good? We did the top two here yesterday. These I asked you to do, okay? Now, if you did not do your homework, now is not the time for you to write it in. I expect that you put the time in outside of class and that when we go through our homework, we are checking. We are not copying. That is cheating. That is academic dishonesty. If you didn't do it, you can do it on your own time and then come check your work with mine later, okay? All right, here is the top part of page 21. Now, this is not a function because every single x value, if I were to plot any of these points over these pretty grids, okay, every single x value is the same. And to function in life, we do not repeat our x's. Yes? Right here? Because, okay, so you're thinking because of the open circles. There is still an x value of 5, even though like the top bottom part, that is more to be considered with the range here and not necessarily the domain. As long as there is some value that's covered, I'm going to include that. Okay? Great question. All right. Let's see. Is everybody still okay making sure that you're including the points that lie on that? You're including that in your domain range. Here is, it's falling on me today. Here is the bottom of page 21. This is not a function because once I pass that vertex, everywhere I move, there are 2 points on that vertical line at any given time. So it does not pass the vertical line test. Okay? All right, and then this one. This one is kind of like the one that we had in our notes yesterday with the exception of, well, it's only like half the line, but that's fine. This is more like a ray. Any questions so far about those? All right, now let me go back to page 22 so that you can look at that. There's the top two on 22. And then here's the bottom two. Uh-oh. All right, do what? So right here? Yeah. Okay, yes, so remember my range is bottom to top. So right here is where it starts, and then those arrows indicate that it's never going to stop. So that's why I did it on up to infinity. For a parabola. Yeah, because these right here, these arrows indicate that it keeps going to the left and to the right. Okay, so there's no stopping that from left to right. But if I'm doing my range, let's see if I can find my blue highlighter. Trying to keep everything the same color that I had it yesterday. It's okay. I've got a blue highlighter, it's just not the same one. All right, now my range right here, this is where it starts, and it, because of those arrows, it keeps going up there as well. So right here and then right there. So there was one, this sideways parabola right here.
So it's sideways to switch it.
Yep.
Okay.
Yep. Okay. Gosh, I almost ripped that up. All right, friends. I need for you to turn to page 23. Okay, we are going to look at domain and range again today, but in a slightly different way. Okay? In a slightly different way. All right, first of all, if I'm given a real world situation, I should be able to determine if that situation represents something that's discrete or separate, or if it's a continuous thing. Okay? So, right here, my question says, Daniel is coaching a basketball team and will have at least 5, but no more than 7 players. He will buy 2 jerseys for each of the players on his team. All right, is this discrete or continuous? Ooh, careful. Which one? I've heard both words. It is discrete. Now let me ask you, okay, what represents the domain? So if I'm thinking science, my x-axis is my independent variable and my y-axis is my dependent variable. What is dependent on what here? The number of jerseys is dependent on the number of players, okay? Now, when we talk about the number of players, that's my domain. The reason this is discrete is because even if I have somebody who is missing an arm or a leg, like they are still a full person. You do not consider someone less because they don't have all of their extremities, right? A person is a person, no matter how small or no matter like what body parts they do have, yes? So, we don't have half a person. That person is a whole person, or they're just not there, okay? Now, the range right here, you guys told me, is the number of jerseys. So, if my domain and range, if this is a discrete function, we have to list out my domain as a set of numbers. We know that that team is going to have at least 5 players, but no more than 7. So what are my options here? 5, 6, and 7. Done. Okay? You can have 5 players, 6 players, or 7 players on that team. Okay? Now, what is the range then? 10, 12, and 14. Because if I have 5 players, the coach is getting 10 jerseys. If I have 6 players, the coach is getting 12 jerseys. And if I have 7 players, the coach will have 14 jerseys. You're not going to have half a jersey. You can't go out there and play with half a jersey. Am I right? They don't even let you play with that shirt tucked in. How many times do I sit at that table and say, get your shirt too? Okay? All right, here we go. Jessica is throwing a basketball in the air. The basketball's height in feet can be modeled with a function of time in seconds after being thrown. The maximum height of the ball, can reach is the 25-foot ceiling, and it will be in the air for no more than 10 seconds. All right. Discrete or continuous? Discrete or continuous? I'm hearing discrete and continuous. Okay, think about the process. The person is throwing a basketball, right? It says The basketball's height in feet can be modeled with a function of time in seconds after the ball is thrown. Can I have half a second? Can I have 3/4 of a second? Yes, you can have those decimals. Therefore, it is continuous. Okay, time is continuous. Okay? Now, time is my what? If I'm thinking science experiments, time is my domain, right? Okay, if I'm thinking about what is affected here, the height of the ball is affected by what? Oh, shoot. Thank you. I wonder why y'all were all looking at me like I was crazy. What represents the domain? Time in seconds. Okay, let's be specific about that. Okay, now the range is dependent on time. What is my range? The height of the ball in what? Okay, the height of the ball in feet. Okay, now, what is my domain here then? All right, so we know 7 has something to do with it, right? So it says no more than 7 seconds. 0, if this is continuous, so say that one more time. If this is continuous, I can have half a second. At half a second after the ball's thrown, can I calculate the height? At 2.5 seconds, can I calculate it? Okay. Right here, I'm going to go 0 to 7. Yeah, because at time 0, the ball still has a height. It might just be where that person is holding it above the ground. Then at time 0, she's throwing it and releases it, okay? She throws that ball. Here's time 0. Let's say the ball is at this height. She throws the ball, and then eventually it's going to come down. What goes up must come down. So right here, this is time 0, and this is no more than 7 seconds, okay? Now, my range here. What is the highest that ball can get? 25. So that's going to be my highest it can get. It can be 25 feet. Where is it going to land eventually? At 0 on the ground, right? So my range is 0 to 25. That ball can be anywhere from 0 feet above the ground to 25 feet above the ground. Okay? Whew, that took a minute, huh? Okay, that's okay. As long as our brains are like working through it. Okay? All right, here we go. Adam's mom is buying season passes for their local pool for her family. The passes cost $6 each, and she will buy a minimum of 2 passes and a maximum of 5 passes. Which of the following accurately represents the domain of this scenario? Okay, first of all, I need us to think about what I'm considering to be my independent and what I'm considering to be my dependent variable. Okay, what is my X value representing here? The number of passes. Now I have a question. Do you think a business is going to sell half a pass? No, definitely not. So, okay, first of all, if I'm thinking number of passes, that should automatically eliminate answer choice A and B. Do you see the difference between these two notations right here? Yeah. This one represents continuous. That means I could buy a decimal of a pass. You cannot do that here. So my answer is D. You can buy 2, 3, 4, or 5 passes. Because this X value means everything in between those two numbers. okay? This is just those individual numbers as a whole, okay? All right, down here, all right, Amy is filling up her pool at a rate of 50 gallons per hour. She will fill up her pool in 6 hours. Which of the following accurately represents the range of this scenario? Now, the range is my dependent variable, okay? What is dependent here? The gallons, right? Or, yeah, my gallons. My domain here is how long it takes. Time is typically always going to be my domain, okay? Everything else is probably going to be my range. Now, right here, we know that it's not the number of hours, okay? My number of hours is time, which is my x-axis. Now, okay, so we got two options here. We go from 0 to 6 or 0 to 300. Now, right here, if my range represents right here the number of gallons, is it only going to take 6 gallons to fill up that pool? No, right? It takes 6 hours to fill up the pool. So if it's filling up the pool at a rate of 50 gallons per hour, don't I just multiply those to know how many gallons is going in? So what is my answer? C. You got to read into these, okay? They're not always going to be straightforward. I'm not just going to take a 50-gallon bucket and be like, all right, there's 50 gallons. Here's 50 more. Here's 50. It don't work like that. If I'm filling it up, I've got the water hose or the whatever in there, okay? All right. Moving forward, you need to have these 3 color highlighters, okay? If you don't have those color highlighters, you need to have something that you can color code your notes with today, okay? Today's is easy, but it can be tricky if we're not paying attention. If you need colored pencils, there should be boxes of colored pencils back there, but you need to have your own supplies from this point forward. Thank you for sharing with your neighbors.
You gotta bring it back, young boy.
Okay. All right, here we go. Today we are looking at intervals of increase, decrease, and constant. Okay? Question. How do you read a book in the United States? Left or right? Japan reads it differently. We're not in Japan, right? Okay? In the United States, where we are, we read a book from left to right. We read graphs the same way. Okay? So, intervals of increase, okay? Increasing intervals. Increase over an open interval. That just means from left to right, never ending, of its domain, if the graph rises from left to right on the interval. So if I'm tracing a graph and that graph is going up from left to right, that is where my graph is increasing. So I've got 2 parabolas here. From left to right, from the left, it's going up until I get right here. On this graph is falling, but then it turns and it starts going up. And those arrows indicate that for the rest of the graph it's going to keep going up. Okay? Likewise, a function decreases over an open interval of its domain if the graph falls from left to right. So as I move from left to right, is it going down? So right here on this graph, when I get to this point up here, does anybody remember what that point is called? Starts with a V. Vertex. Great job. Okay. Right here, when I get to the vertex, it makes a turn and it starts falling from left to right. On a parabola, I have this point right here that is a turning point that is called the vertex. Okay? Now on this parabola, from left to right, this graph is falling first until I get to the vertex and it took a turn. Okay? Then finally, a function is constant over an open interval if its graph is flat on the interval. Okay? Flat or specifically horizontal. That happens from here to here. Okay? All right. So we're going to play around with this today, okay? Here's a lifeline alert. If I'm giving you a lifeline alert, what do you think? Pay attention. Yeah, this is very important. This is going to get us all year long. All year long if we don't get this right here, right now, okay? It is important to note that my intervals refer to my x values. So I write my intervals according to the x values. We are looking at what's happening to the y's. Are they going up? Are they going down? But the whole time, I'm moving from left to right, yes? So we write our intervals according to our x values. Do not miss that, okay? I don't want you to get messed up on that. This is important. We write our intervals from left to right. We write those from left to right. Any kind of interval is written from left to right according to our x value, no matter what kind of interval it is. Increase, decrease, constant, and then tomorrow we'll talk about positive versus negative, okay? All right, flip it over. Now, we read a graph in math the same way we read a book. We read it from left to right. Now, left to right is my x-axis, okay? So I am focusing on my x-axis here. The further I move towards the left, we know that that's going to negative infinity. And the further I move to the right, I'm going to positive infinity, okay? So if I'm reading from left to right, least to greatest, we're going from negative to positive infinity. Always begin on the left side, okay? Now, just to show this to you in a short way, okay? We're going to color code right here. This graph we know is increasing from this point to this point. It's going up. But from left to right, it is increasing from -5 until I get to -2. Do you see that right here? Okay, from here to here, it's going up. So I'm going to say from -5 to -2, it is increasing. Do you notice how I didn't put any brackets on that? Yes. Okay, let me explain why. Intervals. They begin at an x value, they end at an x value. An x value I'm finding from a point. A point is a simple location in space. Like it's just saying, hey, right here, here's my marking spot, okay? Is a point which is zero dimensional, right? It's zero dimensional, it's just a location. Is a point increasing or decreasing itself? No. So I do not care on my intervals to have any brackets, okay? From left to right, all of it can just be parentheses, all right? Next, from left to right, this graph is constant. The next part of this graph is constant. Now, it picks up where the other left off at 2, and it stops being constant at 1. So I'm going to say from -2 to -1, it is constant. Ooh, thank you. Golly, Micah. Gotcha. Okay, we'll pick up there after lunch. Do not be late. There is no try, there is do. All right, much better today. Okay, much better today. All right, here we go. Let's keep going. I just wrote down my constant interval, which happened from -2 to +1. We made that correction. Then my graph starts going up again, so it's increasing. It was increasing from where it stopped being constant. Are here yesterday to hear me chew everybody out about making sure that everybody got back here on time. My class is important, just like everybody else's. Here we go. From 1 to 3, it is increasing again. So what I'm going to do right here, because I have an additional interval, don't forget we're going to join those together with that union. So I'm going from 1 to 3. Okay? And then my graph starts falling. Okay? Now, yes, it is going down. So people very often want to say, okay, if it stops increasing right there and it starts falling at 3, one very common mistake is they want to write that it's decreasing until I get to -5. We are writing from left to right. This -5 is up and down, right? So I'm going from -3 until I get to +5. Remember, we're writing least to greatest. So be very careful that we're going from left to right. It's like a function of time. Okay? So just be careful there. Don't let that get you, because it will. Okay. Now I am asked to consider this function right here, and I'm asked to trace and identify my intervals. Okay? So if I'm reading my graph from left to right, okay, I'm starting over here at the left. This arrow right here means that it keeps going that way. So if I'm reading it from left to right and I'm tracing, I know that this graph is falling from left to right. It is decreasing. Then it turns and it goes up. Then it's flat, so that's constant. And then the last part of this graph, it's falling from left to right. Okay? Now remember, we are writing from left to right. So I'm coming from -infinity and I'm going to +infinity. I want to mark on my x-axis where changes happened. From -infinity until I get right here to 0. What is that graph doing? It's falling, it's decreasing, okay? So I'm going to say that it decreases from -infinity until I get to 0. Then from 0, because that's where my vertex is, okay? From 0 until I get to here, this x value of 2, it's going up. So it's increasing from 0 to 2. Then from 2 to where it does what? From 2 to 5, it is flat, it is constant. So I'm going to write from 2 to 5. All right, and then again, this is where we mess up, okay? Because people see, okay, it's decreasing. So we say from 5 to where is it decreasing? People, a lot of times, what do you think they're going to say? To negative infinity. But remember, we're moving from left to right. So the right side of my graph is positive infinity. You're not writing what it's pointing to. You're still moving from left to right. Okay? This is one of those things where this was one of those no-nos that I talked about. Okay? This is a big no-no. We never have a negative infinity on the right-hand side. Okay? All right. Then the last two questions down here at the bottom of this page ask me to identify the domain and the range of that graph. Now my domain is my x values, and I read that from left to right. I am looking for, are there any holes? Is there anywhere where I would have to pick up my pencil and move elsewhere to continue tracing that graph? It's coming from negative infinity. I keep going, I keep going, and I keep going. Is there any break in that graph? No. So therefore, my domain is negative infinity to positive infinity.
Do we have to write it like that, or can we just put the arcs in?
You could say all real numbers. That's fine. Okay? Now, the range. Range we read from bottom to top, least to greatest. Okay? The range is my y values. Now, I'm looking at my graph, and I see these arrows. What do these arrows indicate? Yeah, that it keeps going, right? So from the bottom, we know that that graph keeps going. So from the bottom, there's stuff covered. Is there any hole or any break in my graph where I would have to pick up and move? No. So once again, negative infinity to positive infinity, or as Micah asked, I could say all real numbers with that double-stemmed R. Okay? All right. Let's take a look at these together. Okay? Now, on number 1, this graph, I just snipped it, so it cut off the little arrows. All right? This is an exponential curve. All right? I am asking you to find the correct intervals for increasing, decreasing, and constant. Now, please remember, with exponential functions, we have this line that my graph approaches but never touches. Okay? Do y'all remember what that line is called? An asymptote. Is that line actually a part of the graph? No. That's my asymptote. That's not part of my curve. Okay? From left to right, what is this graph doing? It's decreasing. And hey, even though it looks like it's going to touch that line, remember, it's getting closer, right? It's still decreasing, but it's never actually going to touch it. So what I'm going to say here, this graph is never increasing. So I'm going to put n/a. This graph is also never constant. The asymptote is not part of the graph, okay? This graph is, however, from left to right, the entire thing is decreasing. Okay? Number 2, from left to right, this entire graph is doing what? Increasing. So I will come in and I will say negative infinity to positive infinity. Do not ever leave anything blank, okay? If I ask you where is it increasing, or I'm sorry, where is it decreasing or where is it constant, you will say nowhere. All right. All right, here we go. This is a parabola. A parabola has an interval of increase and decrease. That change happens at your vertex, which happens at the x value of 2, okay? Now keep in mind, I'm writing that down because that from left to right is where the change happens. My graph is coming from negative infinity. It is falling until I get to 2. And then on the other side of 2, it's rising for the rest of the graph. So it is decreasing from negative infinity to positive 2. It is increasing from 2 to positive infinity. Where is it constant? Nowhere. So I'm going to put n/a, or you can write out none. Okay? All right, here is my vertex for this parabola. The change again is happening at the x value of 2. From left to right, this graph is rising, and then it turns and it falls. Negative infinity to positive infinity. The first thing it does is goes up. So it is increasing from negative infinity to 2, and it is decreasing from 2 to positive infinity. Even though it's going down, I'm still moving to the right. I'm going to put a caution sign right here because this is where I'm telling you that you are going to mess up. It is never constant. Okay? All right, your job for me. In here, do not pack up. I want you to keep working. Your job is to complete 5, 6, 7, and 8. That's it. Okay?